Weather, it affects your life. When a severe snowstorm closes the airport and postpones your holiday ski trip, or a torrential downpour delays the championship soccer game, you blame the weather. Of course, while you may be unhappy with the local weather, you know the snow or rain is caused by much larger global forces. A hurricane on the other side of the world can affect your local weather within a few days. So to really understand weather, you need to look at two things: a local as well as a global point of view. The better you understand what is happening on a large global scale, the easier it is to understand the changes in your local weather patterns. Hello, I'm Cindy Mincer, and today we're going to discuss weather concepts. By the end of this show, you'll have a better understanding of why a sudden change in weather is affected by the power of the sun combined by the Earth's rotation on its axis. You'll discover how the sun, land, water, and air influence global weather. First of all, what is weather? Well, it's the state of the atmosphere for a short period of time. Weather is what we talk about lasting for a couple of hours or a few days. Anything longer than that is considered an area's climate. Climates extend for seasons, years, decades, even thousands of years. Meteorologists, the scientists who study weather, gather weather data from all over the world. This information helps them predict upcoming weather up to a week early. Timely and accurate forecasts are beneficial to people and businesses. Before we can study weather and how it affects us, we need to understand the Earth. The tilt and rotation of the Earth have quite an effect on the weather we experience. Earth rotates on an imaginary axis. The axis is tilted at 23.5 degrees. This means that at certain times of the year, some places on Earth receive more direct, concentrated sunlight than others. The places that receive more sunlight are warmer. Depending on your location, you're either in the polar regions, the mid-latitudes, or the tropics. The polar regions are above 66.5 degrees north latitude and below 66.5 degrees south latitude. The tropics fall in between 23.5 degrees north latitude and 23.5 degrees south latitude and include the equator. Between the polar and the tropic regions lie the mid-latitudes. As the tilted Earth orbits, different areas lean towards the sun. June 21st is known as the summer solstice. It is the longest day of the year for the people who live in the northern hemisphere and the shortest for those who live in the southern hemisphere. This is because the northern hemisphere tilts towards the sun and the southern hemisphere tilts away. During the summer solstice, the sun's rays directly hit the Tropic of Cancer, which is located at 23.5 degrees north latitude. When the Earth moves to the other side of the sun, the northern hemisphere experiences winter. This is known as the winter solstice and occurs on December 20th. The northern hemisphere is now tilted away from the sun and the southern hemisphere is tilted towards it. The winter solstice is the shortest day of the year for those living in the northern hemisphere and the longest for those living in the southern hemisphere. The sun's rays directly hit the Tropic of Capricorn, located at 23.5 degrees south latitude on the winter solstice. Halfway between the winter and summer solstices are the vernal and autumnal equinoxes. The vernal equinox marks the beginning of spring, and the autumnal the beginning of fall. At these times, the hemispheres are equidistant from the sun. This makes the hours of sunlight and darkness equal all across the globe. So, the tilt of the Earth as it orbits the sun has a lot to do with the weather. Different parts of the Earth receive different amounts of sunlight, varying the level of heat in the Earth's atmosphere. Our weather is constantly changing because the conflicting temperatures are trying to balance out. The atmosphere is composed of 4 layers of gases: troposphere, stratosphere, mesosphere, and thermosphere. These layers float above the Earth, one on top of the other, with the less dense layers on top. The troposphere is the densest layer. It begins at the surface of the Earth and extends 10 miles skyward. This is where most of our weather occurs. The troposphere contains the most water vapor, which is essential for cloud formation. An interesting fact, tropos is a Greek word which means churning. How appropriate for the layer where most of the weather takes place. The next layer is the stratosphere. It extends to 30 miles above the Earth. The stratosphere protects us from much of the ultraviolet radiation the sun puts off, and the protective ozone layer is here. The mesosphere is the third layer, and it's 30 to 50 miles from the surface. Scientists believe the mesosphere is the lid which holds in our weather. The thermosphere is the fourth layer of the atmosphere. It stretches from the edge of the mesosphere to over 200 miles above Earth. The thermosphere is theoretically the hottest layer of the atmosphere because it receives the most solar radiation. The blanket of air that covers the Earth goes through a variety of changes. When cold air is blown over a warm land surface, the air is warmed up and rises, only to cool again and sink. There's a constant movement of air in the atmosphere causing all types of weather. Earth is 93 million miles away from the sun. Even with all the layers of the atmosphere, the energy from the sun is strong enough to drive our weather. The sun creates a lot of heat. Heat moves from places that are hot to places that are cooler or lack heat. Think of a time when you felt cold, either because it was winter or you were in a cold room. Well, what made you feel cold was the transfer of your heat energy into the cooler air around you. Our atmosphere is always working with the energy from the sun by moving it around, trying to create a balance. Because this heat transfer process is always happening, it keeps our atmosphere from turning too cold and our land surface from getting too hot. Scientists study heat and its conversion into other energy forms. It's important to the study of weather. Our atmosphere is constantly transferring energy. It happens in three ways: through conduction, radiation, and convection. Heat can transfer from one molecule to the other when they make contact with each other. This is known as conduction. Say you're holding a steaming mug of hot chocolate. As time passes, the heat energy from the mug decreases, and the heat energy from your hands increase until the two are equal. Heat also travels by radiation. Energy is transferred through particle or electromagnetic waves. Radiation does not need to be transferred through matter. All it needs is heat, light, or other waves. This is why radiation waves can be sent by the sun, traveling long distance through space and reaching our planet. Convection is the third way heat energy is transferred. Convection is the up and down motion of varying temperatures of air or water. When hot air or water move, they carry heat. For instance, in the atmosphere, warm air moves up into cool areas and the cool air sinks down into warm areas. Earth is not the only place where convection occurs. By looking closely at the sun, astronomers can see the action of convection. As columns of hot gas rise to the surface, they cool and descend, only to be reheated and rise again. On Earth, convection is essential in the development of wind and ocean currents. As you begin to understand how heat energy is transferred, you can really get a feel for how weather and climate work on Earth. Looking at a globe, you can see that there is twice as much land in the northern hemisphere than the southern. How important is land to weather? Land is quick to heat up during the day and cool down at night. This is where you'll find the greatest temperature difference, and therefore a lot of weather. Land surface makes storms. Imagine a roller coaster of air traveling from the west coast to the east coast. Air rises to pass over mountain ranges and slides down to the other side. The sides of the mountain with the prevailing wind will get cool rainfall. The opposite side, known as the rain shadow side, tends to be warmer and receives less rain. So, as you can see, topography determines somewhat the type of weather that will develop in a place. Land around the planet is different. There are different plants and landforms everywhere. Combine that with the various cloud coverings on any given day, and you have another way that weather is affected. You see, depending on the clouds and the ground coverings, the planet will absorb and reflect the sun's energy in varying degrees. Heavily forested land may reflect 3 to 10% of the sun's energy, while sparkling snow may reflect 75 to 95%. A thin cloud cover may reflect 30 to 50% of solar energy, with up to 75 to 95% reflected by thick clouds. This will cause a variety of temperatures. Look closely at the Earth again. More than 2/3 of it is covered with water. 97% of the Earth's water is in the oceans. That means we have only 3% fresh water on our planet. Fresh water is found as icebergs, glaciers, groundwater, rivers, lakes, and in the atmosphere. The abundance of water affects our weather just like land does. Water and our atmosphere work together to transfer quite a bit of energy between them. Water in liquid form turns into vapor through a process called evaporation and rises to the sky. A molecule of water vapor can remain in the atmosphere up to a week. It will then condense and fall back to the Earth in the form of rain, snow, sleet, or hail, sometimes thousands of miles from where it evaporated. Since most of our water is in the oceans, this is where the large majority of the water cycle takes place. Because of all this activity, oceans have a large influence on weather patterns. For example, warm winds and waters off the Gulf Stream give Western Europe a mild climate. Ocean temperatures remain fairly stable because convection allows underwater currents to transfer and redistribute heat energy for thousands of miles. Because they remain at fairly constant temperatures, oceans help to moderate temperatures along coastal regions. Remember when we talked about the tilt of the Earth and how it affects temperature in different locations? Well, this is true for water as well. The water closest to the equator stores more heat, and it gets cooler the further north or south it travels. Ocean currents move as warm areas migrate to the cold areas and back again. Currents in the northern hemisphere move in a clockwise direction, and currents in the southern hemisphere move in a counterclockwise direction. When slow-changing ocean temperatures and fast-changing land temperatures mix, rapid shifts in air mass causes wind. We've learned that bodies of water and land influence the energy that heats and cools the air. These changes in temperature result in air masses that are hot, warm, cool, or cold. The air masses can form over a section of land or water that may cover many miles. They can develop in a few days or take a couple of weeks. Air masses tend to form in areas with stable air, usually tropical and polar areas. The weather in the continental United States is influenced by several air masses. They are continental polar, maritime polar, continental tropical, and maritime tropical. Many of the continental polar air masses originate over the Arctic. The cold air is warmed as it moves south. If the ground it passes over is cold or snow-covered, it remains bitterly cold. When this happens, it may bring freezing temperatures as far south as Florida. Maritime polar air masses are developed over the cold northern oceans. They are humid and somewhat warmer than the continental polar masses. Continental tropical air masses form over the deserts found in the southwestern United States and Mexico. These masses are warm and dry. Maritime tropical air masses form over the warmer southern oceans like the Gulf of Mexico and the Caribbean. They're warm and carry a lot of water vapor. In connection with the temperature of air masses, air pressure also influences changes in the atmosphere. You see, air is made up of molecules, and its pressure depends upon how many air molecules there are in a given space. It also depends on how fast those air molecules are moving in that space. As air is cooled, its pressure decreases, and likewise, when air is heated, its pressure increases. Squeezing air into less space increases the air pressure. and allowing air to take up a larger space decreases the air pressure. Changes in air pressure are one of the forces that create wind. So how exactly does air pressure create wind? By the difference in air pressure between two places. Let me explain. Imagine two rooms connected by a tunnel. Say the air pressure in room A is 17 pounds per square inch, and the air pressure in room B is 12 pounds per square inch. If you were standing in the tunnel, you would feel wind. You see, air would move from room A to B, causing wind. High pressure will push air toward lower pressure. If the distance between the two rooms is increased, the wind would lessen. This is because the speed of air traveling slows down as the distance increases. Besides distance, an open door or a body slows the speed of air down. They create resistance. This is what happens with the wind on our planet. Mountains, buildings, and wooded areas affect the speed and travel of air. So we've mentioned that air pressure creates wind and that wind has a strong effect on what weather we experience. There is something else that creates wind, the spinning of the Earth on its axis. The Earth is in constant motion on its axis, creating a pull that affects the direction of the wind, called the Coriolis effect. Add this to the uneven heating pattern on the planet, and you get all kinds of weather. Here's how the Coriolis effect works. We know that the Earth spins in a counterclockwise direction. Now, imagine a ball traveling a straight path from the North Pole towards the equator. The ball will look like it is moving in a curve to its right, since the Earth rotates out from underneath it. This is why winds in the Northern Hemisphere blow to the right as they move from high to low pressure. If the ball were traveling from the South Pole towards the equator, it would appear to be moving in a curve to its left. So the winds in the Southern Hemisphere blow to the left as they move from high to low pressure. The Earth is also surrounded by 6 circulation cells or layers of wind. These layers of circulating wind help explain the direction the wind flows across the planet. So, we know that wind moves cold air masses towards warmer air and vice versa. And we know that wind moves in different directions depending on its location. Now, if one mass is moving south towards the equator and one is moving north towards the Arctic, they will eventually meet. The place where they collide is called a front and is usually the middle latitude zones. A front is where the most extreme weather happens. When the masses meet, one of two things could happen. They could stay in place or move with one advancing and the other retreating. If the cold air mass overtakes the warm air mass, it's known as a cold front. The cold air is heavier and pushes the warmer air, making it rise. As the warm air rises, it cools, and any moisture will condense. Clouds will form and release a narrow band of precipitation, often in the form of a thunderstorm. On the other hand, when the warm air mass overtakes a cold one, it's called a warm front. The warm air will slowly slide on top of the heavy cold air. The warm air still rises and forms clouds, which may extend several miles ahead of the front, producing precipitation, usually in the form of rain or snow. Occasionally, an occluded front forms. This happens when a cold front overtakes a warm front and collides with the tail end of another cold front. The warm front that is sandwiched between the two cold fronts quickly escapes from the surface. They typically shed precipitation in the form of rain. When the air masses meet and stay in one place, a stationary front is created. Stationary fronts can be fairly peaceful, with neither air mass advancing or retreating. Even though these fronts can be peaceful, this calm can also mean rain that stays in one place, and the result can be severe flooding. Climate zones have predictable weather patterns. Each of the Earth's regions has different climates. There are 5 basic climate zones on Earth. They are tropical rainy, dry, warm temperate rainy, cold snow forest, and polar. Tropical rainy climates are found near the equator. They are the rainforests and the savannas. These regions are warm with a lot of sun, but also receive quite a bit of precipitation. Dry climates are the desert and grass-covered plains around the world. These areas are very warm and sunny and receive little precipitation. They can experience a lot of evaporation. Warm, temperate, rainy climates are subtropical. They are located on coastlines and are influenced by ocean currents. The nearness to the ocean keeps the seasons mild. Cold snow forest climates are found in the northern hemisphere. These areas are influenced by the size of the land they sit on. Summers can be hot and humid or fairly cool. Winters are usually extremely cold. Polar climates are found near the North and South Poles. The winters are long and dark with severe temperatures. Summers are short and don't receive much heat. Every place on our planet has its own unique climate. Understanding these climate characteristics help us to better interpret how interrelated our local and global weather really are. Even though we've made great strides in understanding weather and what makes it work, we'll never be able to predict this chaotic layer of air 100% of the time. Wow, so many things combine together to make up our weather. The tilt of the earth, uneven heating of the sun, constant churning of air, different types of land, and influences of the water cycle all affect what type of weather we experience. So the next time you're looking at the sky, stop to think about where the weather probably came from and how the powers of the sun and earth combined to create it.
For further information and corresponding materials, consult our teacher resource page at www.teachersvideo.com. For more excellent videos, call us toll-free at 1-800-262-8837 or visit our website at www.teachersvideo.com.